Okay, so today's webinar is about putting some science into your design, and we're going to take a look at utilizing the built-in Express tools, both the structural and the flow simulation tools. With me today, I have two of my counterparts, Damon Tordini. He's been with us for over 12 years. He first started as an application engineer before becoming a simulation specialist. And today he manages both the flow and plastic injection molding simulation tools. His ability to find creative ways to apply analysis tools to challenging engineering and design problems that reduce risk, improve product quality, and innovate are quite amazing. Damon's seen a ton of applications over the years, and we're very lucky to have him with us to share his experience. Also on the line, you bet, Damon. Also on the line, we have Silvio Perez. He's our product manager for the FEA simulation product line. He started in the support group, helping customers use SolidWorks tools, and then was promoted to an application engineer, where he became a certified trainer and spent a bunch of time doing product demonstrations. Today, he helps companies best utilize analysis tools to get their jobs done faster and better than ever. I'm excited for him to share his practical advice on how to best use these built-in simulation tools. Silvio, can you start us off?
Yeah, thanks, Tim. Thanks for the great intro there. So I just want to welcome everyone again. Thanks for taking the time out to take a look at what we have presented for you today. Like Tim mentioned, we're going to focus a little bit more on the analysis tools for SimXpress. So the goal for today is to talk about, what are those Express tools and why we should use them, why they're important, who can access them, how we activate them, and a look into the SimulationXpress tool, and then I'll turn it over to Damon, who will show you the FloXpress functionality as well. But the main thing here, why we're all collectively here, is because you guys have SolidWorks. You guys are utilizing the CAD tool, and that's the first step here to adopt these other functionalities that are available within the Dassault umbrella. And analysis is no different. You see that design is the first stage of this path, and eventually we get to the simulate stage, where we have a variety of different tools to validate your design, to make sure that your design is good enough. And that's really the focus of today's presentation. If we narrow the scope a little bit more and take a look at our analysis tools, you see that we have techniques to test to see how strong your components are through our simulation FEA, or finite element analysis tool. And then we have our flow simulation, or computational fluid dynamics tool, to see how the fluid behavior or the temperatures that are reacting against your models is going to behave. We also have tools like SolidWorks Plastics, which is to be able to test your injection mold analysis to be able to see whether your cavities are going to successfully fill. And then we also have these more advanced tools like SimulationXpress and SimulationXpress that really go beyond the limits of what we have with our traditional tools, and can solve a variety of high-level, more complicated problems with those advanced tools. So you see that we have a wide range of different applications here. But for today, we're going to step it back a little bit. We're going to simplify it here, and we understand that a lot of you guys are working from home, maybe have a little bit more time on your hands, or maybe just doing your normal day-to-day with SolidWorks CAD. But really, between me and Damon, what we really want you guys to do is really expand and really utilize the entire capabilities within your original CAD tools. SimulationXpress is, or what the Express tools are, they're free tools included in all levels of SolidWorks CAD to be used as an easy-to-use first-pass analysis for either your structural or your fluid flow applications. So with SimulationXpress, that's intended more for your structural analysis to see how strong your components are. And your FloXpress is more related to fluid dynamics, where you're trying to see how the interaction of your fluid is going through your system. Now, like I briefly mentioned, this presentation is a little bit more intended for your SolidWorks standard professional users, mainly because through the Express tool is the only option that you have in utilizing some sort of analysis tool to check for strength. Now, if you have SolidWorks SolidWorks Premium, or any of the simulation tool add-ins, then you really should be using those applications, just because it unlocks a lot of the capabilities and a lot of the headache that you may run into with the Express tools. And I'll explain why here shortly. So the main thing here, as far as really what I want you guys to take away from this, especially for those who are not using an analysis tool, is, how are you testing and validating your designs without doing any analysis? How do you know that it's good enough? How do you know that those cool designs that you're doing and those complicated designs that you're CADing up in SolidWorks, that they're going to survive in the environment? Maybe you have questions of, is my part strong enough with this material, or can I reduce material cost? Or maybe you guys do a lot of prototyping and you feel like you don't have to do an analysis, but that's time and money. You have to manufacture that and test it and then break it and redo it again. Well, why not virtualize that within your simulation tools, especially the Xpress tools? They're free. They're for you right there. So really, these virtual testing is really a means of saving time and testing more design options while reducing the cost of manufacturing prototypes. Right? And that's really the main goal here that we have is you're never going to be left in the dark as far as answering the question of, is my design good enough? You really should be testing for that as you proceed through your different design options. So the first thing is, how can we access these tools if you've never turned them on before? So after opening up a CAD model, it's really simple. You just navigate to Tools and then Express Products, and you'll turn on one of those functionalities. You may have to go through you will have to go through an activation process if you've never turned this on before through my.solidworks.com. But I have written a blog activating your SimulationXpress tool that you should have access within your chat menu. So I sent over the link over to everyone. So let us know if you don't have, or if you don't see it, we can resend it again. But that will take you on a step-by-step process of activating that tool and utilizing the software. So let me just show you real quick how we do that. So right now I'm just in the SolidWorks interface. I have my model open here, and we can navigate to Tools. And then on the very top, we have Express Products. And we have DriveWorks Express, which is not related to the analysis side of things, but also a simplified version of utilizing that technique of design operations there. But here, if I turn on FloXpress, you'll see that if you've done this for the first time, you should expect a similar window like this, where it asks you to click on the my.solidworks link, and it'll take you to that web page where you do have to create or you do have to log in to that account. And it's really simple to do. You just need to incorporate your SolidWorks serial number that you can find through Help and About SolidWorks. Punch in a simple questions, and then you're logged in. And it's actually worth your time in logging in and creating an account to my.solidworks, mainly because it's a web portal of a community of SolidWorks users. And you get access to different part files, some training materials, some forum listings. And if you take a look at that blog, it really highlights exactly where the breakdown is of the free version, and there is a paid version of my.solidworks as well. But once you get that activation code, you'll get something, you should get a window that looks like this, where it says your activation code is some random characters, and then your serial number. You can copy and paste that into that box, and you'll never have to do that ever again, okay? So moving forward here, now let's get into the meat of it. Now let's take a look at what SimulationXpress is. And again, it's a free tool embedded in every level of SolidWorks, primarily focused for or intended for your SolidWorks standard and professional users who don't have another option of doing an analysis, any type of structural analysis. So there are some limitations to be aware of, but there's still a variety of different great things that are available within this platform. The first thing is that it utilizes a static analysis, is how I refer to it. A linear static is more of the technical term for a single body part model. And really all that means is just it's a structural stress test to see how strong your component is. But the key thing is that it's limited to a single body. So if you're dealing with an assembly, then you may have to rework it or narrow down the scope a little bit in terms of just focusing on that single body to be able to utilize this. And I'll show you here in a minute how we can do some tricks and workarounds to really take your assembly and full SimulationXpress to be able to utilize that tool. But we have an easy to use study creation wizard, which is what you see there on the window, which takes you on a step-by-step process and never leaves you in the dark in terms of defining how things should be restrained and loaded. It gives you information on the task pane there as you define these conditions. And then you can take advantage and utilize your SOLIDWORKS embedded material database. And that's powerful because there's already a great amount of different materials already given to you in a fresh install of SOLIDWORKS, but you can also take advantage of the custom materials that are available to you, that you have created. You have the option to define a force or a pressure. So you are limited to just those two options. We're primarily, typically, a lot of people use force or use those options, but you don't have options like how you would in the full-blown version, like, for instance, defining a prescribed displacement. What's a prescribed displacement? All that really means is you can define how much a component should move based on a measurement versus how much load. And what's great about that is that with the full-blown version, you can back calculate how much force is required to actually move that distance that you've defined. So there are some of those things that, you know, get unlocked in the full-blown version, but still powerful to be able to use force and pressure. You are limited to just a single restraint that allows you to restrain all 6 degrees of freedom of any face that you define or that you select. And then you have this easy to use solid mesher, which allows you to control how small and how big those elements are as it breaks down the model. And we'll talk about that a little bit more as well. And then we have a one-dimensional parameter optimization feature, which means that it gives you the opportunity to make your design better by allowing you to link it to one-dimensional parameter, let's say the thickness of your component, and vary that to try to find your best lightweight design by still meeting some design criteria. And then as far as results, you get 3 major factors. It's how much your part's going to deform, what the factor of safety is, and how much stress it's seeing. And we'll talk about, you know, a little bit more in depth of what those mean. So let's take a look at, let's see it in action. So right now, what you're looking at is a bicycle crank. So you see we have our pedal, we have our crank, and we are actually in an assembly that's made up of 2 components. So the nice thing about our analysis tools in general is that they're integrated within the SOLIDWORKS CAD, meaning that if you have different design options like what I do here, I can take advantage of configurations and eventually link this to different design studies. Unfortunately, with SimulationXpress, you are only limited to just one design at a time for a single part application. But you can, you know, save these out into individual files and kind of run that test if you are limited to just the Xpress tool. So you see, once I have these 2 components, and if I go to SimXpress, it's going to yell at me and tell me that SimXpress is not supported for an assembly. So what do I do now? At this point, you may want to think about, well, do I really need every component that's inside this assembly? Well, in this case, I kind of do, because I need to apply the load on this pedal to see how much is going to deform the crank, right? There may be some assumptions that I can make where I can get rid of the pedal and apply the load maybe on this particular face, but it's not really going to give me the same effect as if I had the entire model together. So what can I do? So at this point, we can do this workaround where I can do a file save as, and I'm going to change my file type here to a part. So just a regular SOLIDWORKS part file. And I'm going to name this just so I can differentiate, you know, SimXpress, and I'm going to save this out. So once it's saved, you'll still be in the assembly. We can close this out now, and then I can browse to that new file that I just created. Let me found it here, SimXpress. I can hit open, and what we end up doing is we ended up creating a multi-body part file. Right? And you can see that we're in the part file, we have the SLD part file, we have the SOLIDWORKS bodies folder that has 2 bodies here. And at this point, what we can do is we can merge those bodies into a single body by utilizing the combine feature inside of SOLIDWORKS. So I can go into my solid bodies full control on my keyboard, select both of them at the same time, and I can right click on those bodies and hit combine. Really simple to do. You want to set your option to add, and that means that it's going to merge all those bodies together. And just like that, we've tricked SOLIDWORKS into converting this assembly to a single body, and now being able to utilize the SimXpress tool. But you have to be careful, because by merging these two bodies, you're really saying it's one body, and now it may affect the overall stiffness of the individual body. But we'll talk about a little bit more later on as far as what to look out for. But in this case, we can go into Tools, Express Products, and then go to SimulationXpress, and now it doesn't complain anymore. And you see on the right-hand side in your task pane that we get a good introduction as far as what this tool is, how it's useful. You see we have some embedded links as far as being able to utilize some training, take a look at where we can utilize the full-blown model. So really take a look at that once you explore this on your own. We can hit options, and you get options here to convert this from SI units to English. You have options to save where those result files are going to be located, but we can proceed next. And then now we're in the actual wizard as far as taking us on the step-by-step process. You see that it's fully embedded within SOLIDWORKS. It created the simulation tab here, and this is our simulation tree at the bottom. So now the first thing that we have to do is restrain the model. And what's nice about this interface is that it gives us warnings in terms of how far we can take this. It gives us nice animations in terms of what a fixed geometry means. And all that's really saying through these animations is that whatever face we select, that means that it's fully constrained and all 6 degrees of freedom are restrained. And take a look at this last animation here. We had a multi-body part, and it's kind of showing you how you can make assumptions where if that bracket being bolted down to that plate can be assumed that they are restrained, fully restrained, that we can get rid of that back plate and just fix the holes. So really nice there. So let me add the fixture. We get presented to this here. We get that one option, and I'm going to fix it along these 5 faces here, assuming that it's bolted to the actual sprocket that's not modeled here. Okay. So when I hit OK, we can add more fixtures as we see fit. That's all we're going to do here. We can proceed next. And then it's asking me, do I want to add a force or a pressure? I'm going to choose a force in this case. And I'm going to choose these faces here. And you see by default, it defaults to go normal to whatever face I select. I do have the option to do selected direction, which takes advantage of me selecting a reference plane to define the direction of the load itself. We'll keep it here simple as far as normal. I can change this on the fly and say, I want to test for 250 pounds on that pedal, and then hit OK. Right. And then the next thing here, we can define our material. And again, it's pulling up the material database from our SOLIDWORKS CAD. And right now, we have options to create our own custom material and link it to that. Very powerful that we can do that. So on this first test, maybe I want to go to my aluminum category and do a 6066 or 6063, which one? It doesn't really matter at this point. 6061 T6, excuse me. And you see, once I apply that, it's showing you all the material properties here, and the ones highlighted in red are going to be the ones that are really used in order for it to solve the results for this structural analysis. So if you were to make your own custom material, you can just reference one of the existing ones and at least have the minimum of the red properties there. So after I apply, I can then proceed next, and then I can run the analysis. We do have this option here to change settings, and what this means is it allows me to change the density of my mesh. And really the key thing here to really be aware of is that the more coarse this is, the bigger those elements are. That means that less math is happening within every element node, and the more fine it is, the smaller those elements are, meaning the more math there is. So to really explain, what I mean by that is, let me show you this image here, where the more refined mesh means a higher accuracy because more math is happening within all these connective nodes that are going between element to element, but at the expense of solve time. So what that means is because there's more math that's happening, there's more calculation, therefore more calculation time that has to be run in order for it to be able to figure out all those components. But on the left here, you have a really coarse mesh, and on the left, you have a really coarse mesh, and on the right, you have a really refined mesh. So, as you're kind of exploring this, the more refined it is, the more accurate it is, but it does increase your solve time. So you have to be careful about that. In this case, I'll keep it simple. Just leave it at the default, hit OK. And you see that it goes through the meshing process here. It should only take a few seconds here. It shouldn't take too long. But you see that if you were to refine the mesh or drag that bar all the way to fine, you're just going to increase that solve time as well. So now that it's created the mesh, I can run the simulation. That should only take under a minute as well, just because it is just a single body and a pretty simplified mesh. And then immediately once the study solves, you get a visual representation or an animation as far as how the body's deforming. And it's asking you here on the wizard, does it deform the way you would expect? And that's one of the key questions to really ask yourself is it deforming the way you would expect? Should it be deforming the other way? Did I accidentally hit the wrong direction from my load? You can evaluate this before really looking at the results. In this case, because it is deforming the way I would expect, I can hit yes, continue. And the first plot that you see here is factor of safety. And you see that there's a lot of red there. Red is bad in this case, right? Really what that means is it's showing you up against a minimum factor of safety of 1, which really means that in those red areas, it fell below a factor of safety of 1, where it means that it wasn't able to withstand that given load that you applied, where it should present some sort of concern where you may want to do some sort of design change. If you saw that the entire model was blue and well above the factor of safety of 1, that means that not only can it withstand that load that you applied, but that much more times more, depending on the situation. So in this case, we can also take a look at displacement, and you see, it's deforming more in this area as you would expect, just because of it's restrained here and it's free to move in this area. And you see that it's only deforming about 10 millimeters. And then we take a look at stress. And stress, you see that all the areas where it's seeing more stress, in this case, in the actual arm itself, similar to the areas of where the high factor of safety was. And you get this marker pretty much to tell you, how does that max stress compare to the material limits before it starts going into plastic range, or essentially where it starts failing, right? So in this case, that max stress has well exceeded that yield point where we have a concern, right? And that's really how you should be validating these results, is checking to see how much is deforming, to see whether that answer makes sense or relates to any handcuffs or any real life testing. And then you can take a look at the factor of safety to see whether it was even able to withstand that load. But for those of you who are a little bit more experienced with what stress is, you can compare what that max stress to that yield point of the material, right? So at this point, keep in mind that we are within SolidWorks, meaning that we can make a design change or try to change something about this. In this case, maybe I want to go back to my material and change this to a steel material and see what that does. Well, I can go back to my material here, choose alloy steel, let's say, but keep in mind that we're applying the material for all of these components. So that's one of the things to really keep in mind by doing this workaround, is you're really assuming that every component in this assembly is going to be that single material, where in real life it may not. So you have to be careful about that, and that's why these results may be a little bit skewed. But for comparative purposes here, it really becomes an advantageous tool to be able to see if you've improved the design. So if I switch this to steel, we're really just checking that I make it stronger. By what degree did to what degree did I make it stronger? And you see that immediately the entire model is essentially blue, meaning that not only was it able to withstand that load, but it possibly can withstand an additional load, more times of a load for this structure. And when we take a look at displacement, you see that we've decreased it from about 10 millimeters to 3 millimeters, so it's not deforming as much. And when we look at stress, you see that that max stress is well under that critical parameter of the material. So you see that we shouldn't expect to see this to yield at that given load. So we just made a design improvement. And that's just one example of how you can utilize to see, if I compare design A with design D or B, did I make that improvement, right? And at this point, if you're okay with those results, you can animate this, see how it's deforming. we can go into this, I'm done viewing the results, and I can generate a report, send us into eDrawings. But lastly, what you can do is you can optimize the model, meaning that it will turn on your design study parameter here, and you can link this to a single model dimension only, or you can vary the material of this as well, or vary the load that's being applied to the actual model. So you can have the interface make these changes for you and try to define constraints where it shouldn't exceed a certain stress, and then optimize to a goal to, say, minimize the mass. So it kind of takes you from design iteration to optimization all within this wizard, and very easy to use there, okay? So in this case, to recap on what we just did here is, you may be asking again, what do I do if I have an assembly and want to use SimulationXpress? Well, you just saw that we can convert that body into a single body, but you really, if you're a SolidWorks Premium user or have any of the full simulation products, just enable that add-in. That will unlock a lot of the restrictions that we have with SimulationXpress. But as a first pass, try to convert that to a single body if you see fit. But if you see, or if you can assume that those individual components are welded together or glued together where they deform as one body, you can save again that assembly as a single part. But you have to keep in mind that in certain situations, you may be over stiffening the model. That assumption where everything deforms as one and glued together may be making it stronger, but it's a good workaround to be able to test different design setups, to be able to see, you may not even be worried about numerical values, but be able to see a trend to see, did it make it stronger? Did it deform less? Did it deform more? To be able to make better design decisions. So that's really the idea there with SimExpress. Now, how can we take this further beyond SimulationXpress? Well, in order for us to be able to lift that limitation of multi-body parts and utilizing assembly, we can introduce the full-blown studies here, like a static study for assemblies and parts. Or maybe you want to test, well, my structural analysis said that it's going to withstand that load, but what if I want to know if it's going to withstand that load after a certain number of cycles through a fatigue analysis? Well, we can do that here within our full-blown analysis tools, right? So from there, we can reference that structural analysis, take it into a fatigue, and see whether it's going to fail after a certain number of cycles there. But we can take it a step further by the simulation professional tools, where we can test for different modes of failure, such as vibration, through a frequency analysis where we may want to see what the natural frequencies are of your structure. Or if we wanted to be able to link it to different or multiple dimensional parameters within our optimization study and link it to different study types to minimize the mass, it unlocks a lot of capability there with those optimization tools. And then with Simulation Premium, it really gives you everything you see on your screen here, but allows us to define a more complicated study, like being able to see post-yield behavior dealing with plastics and rubbers, or if you wanted to do a more extensive load type, like seeing your structure in an earthquake or driving on a bumpy road, or if you want to see a load happening at a very quick instant. We have a variety of different tools to really add some realism to what may be happening in real life. Okay, so in this case here, hopefully you enjoyed this portion of the presentation as far as SimulationXpress. But now I'm going to turn it over to Damon, who is going to show us the CFD capability.
Thank you, Sylvia. Appreciate it. All right, well, I'm going to go ahead and share my desktop here as soon as I'm the presenter, and we'll take a look at FloXpress. So, like Sylvia mentioned, we've got two Xpress tools built into SolidWorks that are in the analysis family. And we've talked about SimExpress up to this point, which, as Sylvia showed, you can get you pretty far when it comes to a structural analysis of a SolidWorks part. And so its counterpart in the realm of fluid simulation and is called FloXpress. And what this tool will do is let you simulate the internal flow of either air or water through your SolidWorks part or assembly, and basically let you define an inlet or an outlet in that model, such as a flow rate condition, and basically see where the fluid would go in by way of some three-dimensional streamline plots, so that you can evaluate if the design and the geometry you created in SolidWorks is going to give you the type of flow you want and make the fluid go where you want. So let's just look real quick about how you can turn on this tool and then what the steps are that you'll need to go through to use it. So of course, I'm in my SolidWorks menu here. And so as I mentioned just a second ago, this FloXpress tool is going to work on either a SolidWorks part or assembly. So that's one nice thing. You're not limited to only part files as you are in SimXpress. So I can open up this assembly here that I've modeled. It's just a really simple heat exchanger. I've got basically a copper tube, which is welded to an aluminum plate with some fins on it. And of course, in the real world, the idea would be that I would flow probably water through this copper tube and see if I'm able to cool down some kind of hot object that this thing is bolted to. And so I may not be able to simulate everything about this product with FloXpress, but I can start by looking at what the path of the water would be. And so to access FloXpress, you can go to Tools, Express Products, and it's right there underneath SimulationXpress. And again, if you hadn't launched this before, the first thing you need to do would be to get an access code for it, as you would have done with SimulationXpress. It's the same exact place. You go to my.solidworks.com, and with your serial number, you'll have to plug that in and get the code. Once it's been activated, and you can go back here and click on this again, and you're going to get another wizard type interface, although it's going to be on the left-hand side of the screen this time instead of on the right-hand side. And this is going to walk you through the steps you'll need to go through to use the tool. And the very first thing you'll see at this welcome screen is that it's a message telling you that in order to use FloXpress, which only lets you do an internal analysis, you need to create what we would call an enclosed fluid cavity in your model so that FloXpress can figure out where the fluid is supposed to be. So for example, here with this heat exchanger, I've got water that's supposed to flow through the copper pipe. And one of these openings in the model would be the inlet, where it's hooked up to either another section of pipe or to a pump or something like that. And the other would be the outlet. And so what I need to do is in my SolidWorks model, I close off those openings, and then FloXpress will be able to detect that cavity. And there's a variety of ways you could do this. I could go into the part itself for that copper water line, and I could just close up the end. Or if you're familiar with in-context assembly design in SolidWorks, you might be aware that you can create new parts directly from a SolidWorks assembly. For example, here I could go to my assembly tab in the command manager, and I could click my little drop-down button here and say new part. This is what we call in-context top-down assembly design. So I can make this new lid component without leaving my assembly. And so I could say new part, and for example, click on the end face of one of these copper openings, and that's going to create a new part for me, and it immediately gets me into sketch mode as well in that part. And then I just got to model something that closes off that opening, so I could make a big square plate that covers it, or I could use my convert entities tool, my sketch tool, to just click on that edge, hit convert entities, and then do maybe like an extrude to fill in that space there. Anything that will close off that opening is fine. And of course, not only is this helping FloXpress figure out where the fluid cavity is, but these lids that I'm making is going to be the place that I click on to define my inlet and outlet conditions too. So I need to make sure I have some kind of face there. So again, as long as you've modeled something that closes up this opening, you should be good to go. The only exception to that is you have to be careful that when you're modeling the lids, that you don't have something that is only an edge-to-edge contact like you see here. If I extrude that circular profile outwards, that could cause some issues where FloXpress may not be able to detect the cavity properly because it's using the same kind of Boolean operations that SolidWorks uses. And this is kind of analogous to like a zero thickness geometry problem. So you'd want to make sure you would extend the lid into the tube there, or maybe do like a mid plane or something like that. So really any kind of feature is fine as long as it closes off that opening completely. And so I've taken the liberty of doing that so we don't have to rehash it again. And I've got another configuration over here where I've modeled those lids. And so now, because I've done that, when I go back into FloXpress, it should detect my fluid cavity. But we'll have a way to check that. So let's go back here, Tools, Express Products, FloXpress. And so I can click Next to proceed through the setup here. And if I've created my lids properly, I should be able to click this button called View Fluid Volume. And what I'm hoping to see is sort of a blue region on my model, which is where my air or water is supposed to be, in this case, water. So that looks good. Looks like I closed up the openings okay. And of course, if it looked weird or if I didn't see this, then that means I need to go back and check. You know, maybe there's another opening somewhere in the model I forgot to close off, or there's a gap or something like that. Now there's another option at this screen here called smallest flow passage. It might seem kind of weird, and why does that have anything to do with where the fluid space is? And it relates to the meshing that's going to happen in FloXpress. The type of mesh, the mesh technology that this uses is pretty different from stress analysis. It's more of a Cartesian grid. And the most important thing that the mesher needs to know is what's the smallest gap or space or channel that it needs to be captured in your model. In this example, I've really just got this copper tube that's the same diameter everywhere. So I probably don't need to worry about this option too much right here. If that copper tube is, let's say, 30 millimeters, I would just plug that in and that should be good to go. But if, let's say, I had something like one of those fins or the bolt hole there that I was trying to simulate and make sure that I've got air passing through it, then of course I might need to use a smaller number, 3 millimeters or something. And that'll just make sure that you've got a little bit more accuracy in those areas. And of course, that means that there's going to be more cells in the mesh, more math to compute, as Sylvia mentioned. So it'll take a little bit longer, but hopefully it'll be more accurate. So anyway, like I said, in this case, we're only simulating that copper water line. So 30 should be good to go, or even the default value is probably fine. Next, you choose which of the two fluids you want. Inside the water line should be water, so I'll leave that on. And then we come to the inlet condition. So again, most likely in the real world, there's some kind of a pump or something flowing water through here. So I have three main options for how I define that condition. It could be some sort of a known flow rate coming from the pump, or maybe just a known pressure. And before I decide that, the first thing to do is to click on the model where that inlet actually is. And this is the other main reason we created those lids. I'm going to go here and click on the inside face of that lid. That's going to be where the water's coming in. There's different ways you could do that. I could do a section view, or I could hide the copper tube or other things. Probably the easiest one is to just right click and choose select other. And that'll let me pick whatever face is behind the tube there, like so. And then I can choose which of these flow conditions I want. I'm going to say in this case that I know the volume flow rate coming in. Maybe I looked at the pump curve and I have a good idea of what it can do. And I'll put in a value here. This is in cubic meters per second. So you might need to do some quick unit conversion if your pump is in gallons per minute or something like that, or if you've got an air flow rate in CFM. But I can just plug in a value there, let's say 0.005 cubic meters per second. And I could also change the temperature of the water coming in. And if it's supposed to be really cold water, that will affect the properties like the viscosity a little bit. So then I can click next and do the flow outlet. You get one of each. And of course, that's going to be the other end here. Just right click, select other, grab that inside face of the lid again. Has to be the inside, you can't click the outside, unfortunately. And then this value is supposed to be the pressure on the other side of that lid, basically. So whatever the pressure is that the water will be flowing into, if that's like a big open tank, it's probably just regular atmospheric pressure like I've got here. That's the default number. But if it was flowing into like a larger section of pipe or a coil or something like that, maybe it'd be a higher pressure and I'd type in a larger number there. Okay. And so that's it. You're pretty limited here, but it also makes it real easy to set up. And so at this point, I can hit the play button, which is going to solve my FloXpress study. And you get a little preview of some other examples there of things that the full version of SOLIDWORKS Flow Simulation can do, which we'll touch on in a moment here. And as soon as this is done, it's going to automatically pop up the type of result that we talked about, which is going to be my flow streamlines. Again, this part of the FloXpress wizard is just going to depend on how complex your model is and what value you put in for that minimum flow patches setting. If you had a lot of very small fins that were trying to be simulated and you put in the gap size for those fins, that would add a lot of force. By the way, while we're talking about it here, both the SimXpress tool and what we're looking at here with FloXpress are using the same basic solver as the full version of these products. And if you're not aware, the solvers do utilize multiple CPU cores. So of course, if you have a modern processor with, let's say it's an Intel Core i7 with 6 physical cores, they'll take advantage of all of those, and in addition to the clock speed. So that's one of the most effective ways you can speed up a simulation like this. Of course, RAM is important as well. Sylvia, I'm not sure how much RAM you've got. I'm at 16 gigs right now, which I guess is good enough for me to not complain. And that'll control how large of a simulation you can run.
I won't tell you how much RAM I have, sorry.
Okay, I have a feeling I need to do some espionage here. All right, so our FloXpress solver is just about done. And as you can imagine, the calculations for fluid dynamics are sometimes a little more complex than structural, so it's normal that this would take a bit longer. And as soon as the solver finishes, you can see there it's loading up my results. And at the next screen, what I've got are those flow trajectories that we talked about. And by default here, what you see are what we call pipes, which is basically just a constant, a solid line of the flow from inlet to outlet. And it's colored here by velocity. So for example, this is saying that at the inlet, based on the flow rate I put in, I've got something around 25 meters per second of velocity to my water. And it speeds up a little bit as it gets down the first bend here. And that seems to mostly be because there's some swirl that's getting introduced. And then of course that happens again and again for each of these bends. So that's about all I can see here, although there is a different way I can view it by switching the animation mode here to what we call balls or spheres. And that way you can see more of a dynamic animation where it's almost like you see the individual particles of the fluid kind of moving around. That sometimes is an easier way to visualize it. And just like what Sylvia showed you before, at this point I could make a design change, maybe change the diameter of my tube, or maybe make one of those bends bigger and see what that does. Maybe that reduces the amount of swirl, maybe that changes the velocity. I can also, of course, take a quick screenshot here if there's an interesting view that I see and I want to save. Maybe I'll go here to pipes. And I can use this little button down here called Snap Image. That'll kind of go into a little thumbnail preview. And that will let me click this Generate Report button, and it'll throw that image into the report, which, just like SimXpress, is a simple Word document, which you can then modify and, of course, put your name and description on there and send it off to whoever might be interested. Okay. So that's a simple internal simulation of water flowing through the tube. If I wanted to simulate the airflow side of this thing, figure out what that looks like going through the fins of the aluminum heatsink, I can't really do that as is because, as I mentioned, FloXpress is meant for internal simulations only, but there is a bit of a workaround, which is I could save this model out and to another copy and basically model a big chamber around it. And so in this example, I've made a big box. And now I can basically do another internal analysis, except the internal space is going to be the airspace inside this container. And that'll simulate the air flowing around the heat exchanger fins. And you do have to save the model out, though, to another copy, as I did here, because you're only allowed to have one FloXpress study per file. So it's one limitation there. But again, you'll be able to set it up in the same way as before and see things like the airflow patterns around the heatsink. So just to recap some of those workarounds, again, we didn't have to do any kind of save as part or combining bodies because FloXpress will work as an assembly, but we did have to save the model out to another copy in order to model a box around that in order to simulate the airflow. So FloXpress is for internal simulations only, so sometimes you have to model some other kind of container to sort of trick it into thinking that the external airspace is internal. Another thing that you may have noticed is that you only get to put one inlet or outlet condition, or one of each, I should say, in FloXpress. And of course, there's a lot of models where you might have more than one opening. And there's a workaround to that as well, which is that you can cover the multiple openings in your assembly with one big lid. And that way, there's still going to be one face that you select when you're going through the FloXpress wizard, and that'll trick it into thinking that it's really just one outlet. So as long as all of those openings are meant to have the same condition, for example, the same outlet pressure, that'll work fine. Now, of course, if I wanted to go beyond what FloXpress could do, that's where the full version of this product comes into play, which is called SolidWorks Flow Simulation. Still runs inside of SolidWorks, but of course, it's a separate serial number that you would get. And that would open up a whole realm of different kinds of physics that you can add into your simulations, the ability to do internal or external simulations, things like aerodynamic flows. You do lots of different types of fluids or even mix different types of fluids like a gas mixture or injecting one liquid into the other. And of course, you could do heat transfer. So things like thermal analysis, or I could, in this heat exchanger model, open up the conduction through that aluminum plate. There's even some add-on modules for flow simulation that are kind of industry specific. If you, for example, design a lot of circuit boards, there's an electronics cooling module, which gives you some special ways to define the components on the circuit board or even the layers of the board itself. There's also an HVAC module for simulating basically human environments, any kind of heating, ventilation, and cooling situation where you might want to factor in humidity or figure out what the sort of industry standard comfort levels are for different types of environments. In the example of this heat exchanger model that I made here, with the full version of flow simulation, what I was able to do is simulate the water flow and the external airflow at the same time. You can see I've got some air coming in from the side with the velocity vectors there. And I've got the heat transfer factored in too, so that I'm seeing the actual solid temperature of the aluminum. Of course, that would let me specify the materials there, copper waterline and the aluminum plate. And I'd also be able to figure out things like the transient behavior and really get the physical numbers, the physical data that I'm looking for, such as what's the actual temperature of the water at the outlet, and maybe what's the pressure drop in the system. Maybe that will help me size the pump that I'm trying to pick to run this thing. So of course, it goes beyond the sort of qualitative result that FloXpress gives you in visual streamlines and gives you the real numbers you need to pick one design revision over the other. Of course, there's a lot of companies that have used the full version of these SolidWorks simulation tools in practice. One that's kind of relevant right now is a German biomedical company, Draeger Medical. They have used SolidWorks simulation and flow simulation for several years now, over a decade, I believe. They've used SolidWorks simulation to optimize the design of some plastic parts in an anesthesiology device. That's what you see on the left there. And they've also used flow simulation on a wide range of products, which includes a line of neonatal ventilators. So of course, any type of ventilator is in high demand these days, and I'm sure that they are happy that they've put a lot of work into figuring out how to make those devices as efficient and as reliable as possible. And according to some survey data they submitted, they were able to in both of these cases, sort of predict a particular defect in the design they hadn't caught earlier, and it saved them quite a bit of time and money on each prototype. And of course, that's the general idea with simulation, regardless of industry or application. And that's kind of one of the things that we at Hawkridge pride ourselves as being experts on, whether it's providing technical support to our customers or conducting training classes or any of the free content that we put on our website, like this webinar. We think we're pretty good at this point at giving you advice on which of these simulation tools might be the best as far as predicting what you need it to predict and maybe the best ways and methods of using those tools. So if you have any questions about something that you've used SimExpress or FloXpress for and what you could do further with the rest of the SolidWorks simulation products, feel free to give us a call and we'll be happy to help you figure it out. With that, thanks everyone for their time. We're going to hang out here and see if there's any questions we can wrap up. Tim?
Yeah, actually, Damon, if I can take back the presentation from you.
Sure, do that.
So just to add a little bit more on what Damon just mentioned, which by the way, great job, really cool stuff what you can do with FloXpress there. You know, to get a little bit more information as far as, you know, where we stand with SimulationXpress and FloXpress, we have attached a handout in the GoToWebinar panel that you can download, the Simulation Buyer's Guide. And that will really explain how far we can take it with these Xpress tools and what other tools you should be considering depending on the application. And that will really narrow down the scope as far as what level of simulation is good for you. But I did want to go over this one question that came up, which asked, and I'll quote it here, if I have SolidWorks Premium, does that mean that I have access to all the tools for simulation? So I just want to clarify that with your SolidWorks Premium license, gives you the capability to do linear static analysis and kinematic rigid body motion. So these first two tiles here fall under the category of the highest level CAD package that's available. So if you have that license type, then I definitely recommend going into tools add-ins and turning on the simulation add-in, which only gives you that structural tool. So very similar to what I showed you in SimXpress, but unlocks a variety of different tools like the types of loads, how you can mesh it, you know, how it can be restrained. So if you have that option, definitely take advantage of that. But if you have SolidWorks Professional or SolidWorks Standard, notice that we don't have an analysis type option here. It's part of just the free utilities like what we just saw today.
And just to add to what Silvio is saying too, if you do decide to add one of the SolidWorks simulation products to get into those higher capabilities like fatigue and so forth, just keep in mind that will relate to the structural analysis tools similar to SimXpress, and flow simulation is kind of a separate decision. So you don't have to buy any SolidWorks simulation package just to get access to flow. It's kind of its own thing that you can add to any SolidWorks license.
Yeah. The benefit though of having both products, the structural, whether it's from SolidWorks Premium or the higher levels, is that they do communicate. You know, and that's really the key thing, is that these SolidWorks tools communicate with each other, where if in the full-blown flow simulation study you ran a thermal analysis and you wanted to see the thermal stresses, you can throw those thermal results from flow into your structural analysis and see how much is going to thermally deform and stress based on those thermal results. So we'll hang on here for a minute or so, but again, hopefully you enjoyed the presentation today. It will be posted shortly, but definitely take this time to ask any other questions that you may have, and we'll be happy to answer them for you.
And while we're waiting, I'll mention one other thing on the point you mentioned, Silvio, about the tools working together. I found that in a lot of cases, even if I don't intend to use the direct load transfer from, let's say, flow to stress analysis, I tend to use them together anyway, just to see if a design change I make is going to have a positive impact on one sense of the design and a negative impact on the other. You know, for example, there's plenty of cases where I've looked at the flow results first, and you know, being a CFD guy, I'm a little biased. I want to punch a bunch of events into my design, and I'm sure that'll improve the airflow, until I remember that when I go back to my stress analysis, I've just taken a huge chunk of material out of that thing, and it's not so strong anymore. So it always helps balance and lets you do a proper trade study for every product that you're designing to figure out what are the sort of limits of the design space. How far in one direction can you go without hurting something?
Yeah, that's a great point, Damon. Yep. And you know, we've definitely done presentations where we've shown that, right? And you know, for those of you who have access to our YouTube channel, you know, Damon and I have done these types of webinars. So under that simulation, you know, section, we have some examples of that. But you're right, Damon. I mean, you move the lever on one end, and you may affect the lever on the other, and that's really the great thing of having these tools integrated, is that the streamline between the two is very effective versus if they were external.
Yep. Just change that model and hit run.
Yep. Just want to thank everyone who's still on, and maybe we'll see each other on the next webinar, but definitely check out for those emails for additional webinars that may be coming up for a variety of different topics. But I hope you enjoyed this one, and take care, everyone. Have a good one.
Thank you.